And hello everyone, welcome back to a new video. Today we will be learning about OOP. So what exactly is OOP? OOP is object-oriented programming. Up until this point we have been working on procedural programming or functional programming, where basically we have a bunch of functions and those functions create our application. For example, if we had a function and we called it main, and then inside of this main, we did everything our application will do. That is considered functional programming because we will have multiple functions, and all of these functions will do something. So do, and we call this something, and here we can call do and something, whatnot. And that is functional programming, where you have a function and that function executes other functions, and it's just a bunch of functions to create your program. That's what we've been doing up until now. Now we will be learning about object-oriented programming. And it is just a way of thinking. Because let's say you're developing a game. Now you could do procedural programming in game development, there's nothing wrong with it. But when you create a game, the easiest way to think of that game is as an object-oriented programming way, where everything in that game is an object. That trash can that the player walks by, that's an object. The player itself is an object. The bike the player rides on to get to their hood, it's an object. Everything in the game, the houses, the streets, everything, that's an object. And that is what we are thinking of when we think of object-oriented programming. Object-oriented programming isn't just useful in games. OOP, object-oriented programming, is also useful in real-life situations where you can have a bunch of objects to create an application instead of using functions. It's up to you which you prefer doing. I usually switch between the two depending on a project. So now that we've got that out of the way, we also need to get out of the way that Lua is not an object-oriented programming. Python, C++, Java, C#, these are object-oriented programming languages. They are meant to be used in an object-oriented way. You create objects, classes, to make things work. Lua, however, is just like C. It doesn't have objects. So to create objects, you have to simulate it. And because of this, that means there's also a lot of ways you can simulate objects. I'm only going to show you one way of doing it, because this is the easiest way to do it, and to be honest, I can't understand any of the others because my brain not big enough. But let's get started. So if you don't understand what object-oriented programming is, you still have a little bit of a foggy mind. I believe if we go into the code right now, it should be able to help you get around to understanding it. So to simulate object-oriented programming, we are going to use functions. Functions in order to simulate it. Those functions will return a table, and that table is what's going to help us create the objects. Because with a table, we can create basic objects. For example, if I go and create a local table, then this table can have an object that has like the name instead of it. We can say Jack. And it can have another object, and this can have the age and the, let's say, friends. Now the age, we can make that something like 18, and the friends, we can make that another list, and that just keeps the names of his friends. He only has one friend, so we can call him Jack. I mean, Fred. We can call his friend Fred. There we go. This itself can be considered an object if we use it right. Because if we go to print, then we can use t.name as an example to get the name of this object. So if I say Lua and I run my file, then we get Jack. So we can use this to our advantage to create OOP. So let's create a function. I'm going to call it a local function, and it's going to be called pet because we're going to simulate a pet. This pet will take in a name because we need to give that pet a name. It's optional, it doesn't need to take in data, but it would be nice if we can create a pet, and that pet, let's say we can call it Ginger. And this should be a function, so a function, and it will be pet, and in here we can just say end. Now, what we can do is we can return a table. And whatever inside of this table is part of the object. That means we can put functions in here. We can put normal, just like names and ages in here. So for example, let's say name. And this name can be equal to the name we give it. So we give it a name on initialization. We didn't need that. For right now, let's just do that and call our cat or our dog or whatever, we can call it Lewis. Now here, after that, we can maybe give it a status, like how is it feeling right now. In this case, we can say it's hungry by default because you need to feed it. And we can use this now as an object. So down here, we can say local cat is equal to pet. We have created an object. And this cat right here basically is part of the object. So now here we can say cat.name. And we can get the cat's name. So if we were to wrap this inside of these and were to say print, I'm just going to remove everything up here because we don't need it anymore. Then we get Lewis because the cat's name is Lewis. Now the reason I want to put a name in here is because then you can give your cat a special name. So here we can, instead of saying Lewis, we can say name. If you wanted to, you could say name is equal to name or Lewis. Which means if they don't enter name, it's going to default to Lewis. And here we can just maybe say Kitty. And then we can create a dog, just for the heck of it. We can say dog. And dog's name can be nothing. That will be the default name given. Then here we can have a name for the cat and the dog, so we can print out both of them. Now if we save and run this, you can see we get Kitty for cat and Lewis for dog. And that's object-oriented programming. These two are two different objects. They basically use the same object, this pet object, to create their own little object. In fact, we could have used a car in here and say, this is a car, and it can be, and these are the parts inside of it. And then you can give the tires a specific type and whatnot. But that's too complicated. So I'm going to stick with the simple stuff here. And now we can modify both of these and they will not be taken into modification. Like if we were to change the name of cat here, it will not change dog. And we'll get to that in a second. Now as good practice, we also capitalize the first letter of the function. This is just so we can actually know this is an object. So if you want to, you can even go pet and then something else. And you can use camel case where the first letter is capital and not lowercase. But yeah. Now let's say we want to be able to feed our pets. Now to do that, we can create another thing. And it's not necessary to add an extra space here as I'm doing right now. But I just like to do it so I can keep my functions and my these out of the way. And feed can be equal to a function that takes in self. And then we can just say end. And in here we can write something that should happen. Now this self right here, that allows us to access things inside of this table. So if I want to access this name, then inside of this table I can just say self.name. In this case we want to change the status. So I'm going to say self.status, and this will allow us to use the status. If we don't have self here, we might get errors. But then we can say is instead of hungry, you can say full because they have been fed. You can just make that a capital H as well then. So now let's just remove dog here, and then we can say, and we can also remove that name there. Then you can print cat.status. This will print what their status is. We can then put 3 things here, and the second one is where we're going to feed the cat. So we're going to say cat.feed. And here we can show the cat status again. So let's see. And my bad, that should not be dot, that should be colon to access that feed. Now if we run it, we get hungry and then we get full because the cat was fed. And now we can even maybe add extra details so we know the cat is being fed. So again, here we can print, and maybe we want to put a name here. Name is fed. Now, whenever we run it, we'll see Kitty is fed. And the nice thing here is if I were to create another object here, and let's make it dog again, and we don't have to give it a value here, we can just keep it default. If I were to show the dog status, so dog, it would still be hungry because cat and dog are their own objects. So if we run this, as you can see right here, it's still hungry because dog is not cat. So whatever happens to cat here does not happen to dog. And that is the power of object-oriented programming. You can have multiple objects, but with different values. So yeah, that's one way to do it. Now I'm going to show you how to do it in another way. And this is going to be inheritance. Sometimes you want subclasses for your classes. Classes that inherit of something else. Like let's say you have a dog class you want. Then you can inherit from a different object. So here I can maybe say and create a local function here. And this can be called dog. Now dog, we might want to take in the name and maybe even the breed of the dog. Then instead of this, we can say local dog is equal to pet, and we can give it a name. What we are doing here is called inheritance. We are taking this dog and we are making it this right here. That is what's happening here. And later on we can just call dog where local L is equal to dog. Just so we can have it here. And we call it maybe doggy. And it's a poodle or something. Okay, so we are inheriting from this pet. We are making this dog equal to this pet value right here. Now we can create our own little dog object that's part of the pet object by now saying something, for example, like dog.breed. So we are adding to this. We're adding to this table right there. So dog.breed, and here we can pass in the breed. And that should be equals, because it's not a function, it's a value. I can do this like with a bunch of things. We can even say loyalty, because we all know dogs are pretty loyal. And it starts by 0, because if you just get a dog, who's to say that dog's going to be loyal? And now we can say dog dot is loyal, and we can make that equal to a function that takes in self, because we need to access this loyalty right there. And we can return, return self.loyalty and bigger than or equal to 10. So this just returns true or false. So if the loyalty is more or equal to 10, then the dog will be loyal. If it's less than 10, then the dog will not be loyal. Also, it doesn't have to be camel case, you can do that as well. I'm going to use camel case for right now. And you can even maybe go dog.bark. Dog.bark can also be a function. I mean, this function is executed. We can also test take in self. It's just, you don't need to take in self here, but it is recommended just so you always know this is part of this self. It's part of this right here. It's just optional. You don't need it here in this scenario, but it's good practice to have it there. And you can say print, and you can say woof, woof. Now it will bark. So here, if we want to go Lassie, for example, then now we can call the dog Lassie. And now it's a more specific object, because this object is specifically a dog, and now we can specify here more what it is. Now here we can print the dog, I mean Lassie, dot, and let's say breed. We can pass that in, so now we can get the breed of the dog. So we go here. My bad, I was supposed to go here and say return dog, because remember it still needs to return this table right here, because we created a table, we modified that table, now we need to return that table, just like we did here, but now it's just put inside of a variable first and then it's passed in. So we didn't even need to do this, we could have just created a table here, but then inheriting would have been a little bit more difficult. Anyhow, so we can save this and then we can try to run it. And we get a poodle because it's of breed poodle. Now next up, let's say we want to make our dog bark. So you can say Lassie.bark. Or actually, so you go :bark. And there we go. If we want to access a function, we'll need to use colons. If we want to access a variable, then we can use a dot. Do that, and now we get woof woof. Now let's go here. We can maybe even go if Lassie dot is loyal, or actually is loyal. So if the dog is loyal, then we want to, let's say, print will protect against intruder. So let's say if there's an intruder in your house, then they will. Else, we can print, because they're not loyal, they will not protect you against intruders. Will not protect. Let's save and run that. And as you can see, will not protect against intruder. Now let's say we wanted to increase this loyalty right here. Now what we can do is we can say dog, and let's give it a nice function we can use. Something that will make sense, because usually if you feed a dog, they also become more loyal. So we can say feed. And what we're doing now is we're overwriting this feed right here. We're overwriting it. So we're changing it to be something else. So you can do that if you want to. And that is equal to a function. And we can say self. And now we can overwrite that function. So instead, we can actually copy this for right now. So instead of it's changing the status, and also just so you know, if we comment this out, we can still access the status. If we print Lassie.status, whoops. If we print Lassie.status, we'll still get a status, hungry, because status is what's inside of this table. And that table is being passed in here. We're just adding to that table. So we can still use status. And this is where self really comes in handy. Because now we can reference to the status we can't see here. But we know it's part of this specific object. So now we can say they were fed. We can change their status to full. And now we can add to it. Now we can say self.loyalty is equal to loyalty, self.loyalty plus 5. So if we were to feed our dog twice, then theoretically they will increase their loyalty. So now I can say Lassie and then feed. They will still not be loyal. If we do that, Lassie was fed, not loyal. But after the second feeding, they will become loyal. Will protect against intruder. And that is actually all I want to show you. So I'll go through this once again. So we're creating an object, and this object can be used on its own. You do not have to create this sub-object we have right here. You don't need it. But this object can be used to create other objects or to create variables that allow them. So if we want to do, we could say cat is equal to pet, and we're going to say Blas. And that's perfectly fine. There's nothing wrong with that. But what makes object-oriented programming so good is that we can create other objects to go over that object. So here it returns a table, and we can put that table instead of a variable if we wanted to. So local tbl, for example, is equal to that, and then just return tbl. There will be nothing wrong with that. If I were to run this, we'll still get the same output, as you can see here. But I just like doing it like this because there's no reason in putting it inside of a variable first. But once we created this object and we create another object of it, we can treat it as its normal object and add more functionality to it. So for example, let's say we have chefs. Now a chef that specializes in fish, for example a sushi chef, they won't know how to make ratatouille, for example. But the chef that is in a restaurant, so the restaurant chef, will probably know how to make ratatouille. So you could have a function for that chef that says make ratatouille. And you can have a base chef class, which has all the default things all the chefs should have. Then you can have a sushi chef as a subclass and a restaurant chef as a subclass, where the restaurant chef can create ratatouille, but not sushi, and where the sushi chef can create sushi, but not ratatouille. And then you can use those in, let's say, your game, for example, where every object has a different way when you interact with it, but they're all part of a base object. For example, you might have an entity object, and your player, your enemies, and any other NPCs in the game will maybe extend from that entity object. And what we did here is extending. We created a subclass. I hope you all understood this. OOP can be a pretty difficult concept, especially for beginners to grasp. So if you didn't quite understand it, what I highly recommend you do is to create a game. Create a game where you have a bunch of things in it. You need a player, you need enemies, you need NPCs, or just people you can talk to in the game. It doesn't need to have a GUI. It can be in the terminal here. You can have like a bunch of yes or no answers and stuff like that. And you can do it with functional programming, where like creating RPG, that's probably the best idea. You can do it with functional programming. And if you find out that functional programming makes it difficult, try to do it with OOP, because I can almost guarantee you OOP will in some sense make it easier to create that game. But that's all for today's video. Thank you all for watching. I hope you all enjoyed, and I'll see you all again in the next Lua tutorial.